Average velocity. The average velocity is the distance divided by the time. So here we have that the distance is a function of time, and to work out the average velocity is the gradient of this line. You'll see here we've got the function t2 and t2 itself, function t1 and t1 itself. So the gradient of that line, which is the average velocity, is equal to st2 minus st1 all over t2 minus t1. As simple as that. And that is actually, you can see, the secant. In this particular example here, we've got that the function of time equals 30t minus 5t squared. So we first of all have to work out S2, and that's 30 times 2 minus 5 times 2 squared, and that's going to give me 60 minus 20, which equals 40. Obviously S0, when you put 0 in here, it's just going to be 0. So the average velocity is going to be simply 40 over 2 take away 0 is just 2. So it's going to be 20, and if this is in meters, it'll be in meters, and that was in seconds, it'll be meters per second squared. Meters per second, sorry. That's the final answer. The next example is a little bit more involved. But we do exactly the same thing. We're going to substitute in 3 for t here. We get that S3 is equal to 2 to the power 3 minus 2 to the power minus 3 all over 2. And that becomes 8 minus 1 over 8 over 2. And that gives me, on the calculator, 3 and 15 sixteenths. Now when you put in the next one, S1, we get 2 to the power 1 minus 2 to the minus a half, so minus 1 it should be, jumping ahead, over 2, and that becomes 2 minus a half over 2, and that becomes 3/4. So when you work out the average velocity will be the difference of these two, 3 15 sixteenths minus 3/4 all over, right, the difference in times, 3 take away 1, and that all comes out to 1 and 19/32 on your calculator. Meters per second, if you want to, that was in meters, and the other one was in seconds.